Which one of the questions is it?
Well, I have like a general question.
Oh, okay.
And also a question on number 5. But the general one is if it doesn't use the word proof in the statement, don't set it up as a proof.
Right.
Okay, so like number 4, it doesn't have to be complicated. You just
Show it. Yep.
And then for number 5,
1 through 5 don't write formal proofs. 6 and 7, 9 and 10 do write proofs. Okay, what else? Sorry, I interrupted you.
For number 5B, so for A, to determine if it wasn't composite, you find something that makes it not composite, as like an integer. And to do the same with B, I'm unsure, like, do I just go through all the numbers, or is there a method to figure it out?
I would factor.
Okay.
So B, this factors to what, n plus n squared? Right? So then figure out what m and n can be. Which the only, yeah. Since they're both greater than 0, well, I guess the only thing it could be is if they're 1 would be the only time it could be prime. And that would be 4, and so that wouldn't work. Yeah. So then you would say something like m plus n is greater than or equal to 2. So neither of the factors is 1.
So it can
Because n then is greater than or equal to 1, and n is greater than or equal to 1, right? So then m plus n will be greater than or equal to 2, always. So m plus n, so the point is that this number isn't 1, so it times itself is not going to be prime. I wouldn't even do that, like looking at it like this is m plus n times, Lord have mercy. My gosh, m plus n. And so if it was prime, then one of those would be 1. And neither of the factors can be 1, which means the other one isn't n plus, isn't this thing. So it's not prime. We'll go through one of those today, like a proof of one of those today.
Oh wait, for number 6, how would we do a proof for it, because it's not saying all integers m and n?
So a real proof there is just find an example and show that it works.
Okay.
Yeah, consider m equals this, n equals this, so 1 over m plus 1 over n is this. That's an integer. We're done.
Okay, so we still have to do like scratch work proof.
You don't have to do the scratch work. You can just write the proof part. Just write it formally. Same with 7. Like you're proving that there is an integer where that's true. So all you need to do is find the one where it works. Find one where it works. And do you want to go through the rest of the proofs on the note packet now and then come back to homework questions, or what? Does that sound good? Okay. Oh, wait, let me fix your homework 4. Y'all have that homework 4 in front of you now. The typo is on number 2. Oh, well, whatever, it's a mistake. It's not really a typo. I didn't put the squared there on the end, and that's important. It makes the statement work or not work. So it's 6n squared plus 27 is prime. Good?
Yes.
Okay. Notes. Okay, so we went through these. I'm going to write stuff down today. Does that work for you? We went through them. I don't know what today is, Monday. We went through them on Friday. But I'm going to go through and like write stuff now if that works for you. Or if you like me to do something else, I can skip them and just write proofs. What do you want me to do? Write them down? Okay. So these are mistakes in proofs. We're going to figure out what's wrong with each proof, okay? So on number 1, I would, start with the statement. And it says the sum of any 2 even integers is even. Then you would start your proof with a proof. This is true because if m is 14 and n is 6, which are both even, then m plus n is 20, which is also even. So problems are, this is an example, not a proof. This is an example. That's a proof for there exists, right? Another problem is that they didn't use the definition of even. And I would also say that they need a box or a QD or whatever. Questions about number 1? Okay, number 2. This is just a piece of a proof. Suppose m and n are any odd integers by definition of odd. M is 2k plus 1 and n is 2k plus 1 for some integer k. What's the problem here? Yeah, they assumed that m and n are the same odd integer. So you want to use something like k1, k2, or k and l, or some possibly distinct integers. Don't use the same variable. That's the point. Unless you mean to use the same variable. Okay. That's the only thing with that one. Any other questions about number 2? I have some writing here. I don't know why. Number 3, the sum of any 2 even integers is even. Again, there's your statement probably that you should identify as such. You should start your proof with proof. So suppose m and n are even integers. By definition of even, m is 2r and n is 2s for some integers r and s. So far, I'm okay with that. Are you guys? Oh, except for the misspelling of suppose. Also, some people really don't like using the word suppose when you mean to assume. Whatever, it's fine. Okay, so then we have m plus n is 2r plus 2s, so m plus n is even. I think this is a little too much too fast, so we're going to say that this is equal to 2 times r plus s, and then we're going to say something like because or since r plus s is an integer, 2 times r plus s is even. Therefore, m plus n is even whenever m and n are even.
I know for like the homework it says like because the sum of 2 integers are integers.
Yeah, I think that's too many words. We're going to assume like we said, the integers are closed under addition. We're going to accept that as fact. We don't have to say it every time, but you do need to mention like, hey, reminder, this fits the definition because this thing is an integer. I don't think we need to write anything else on number 4, do we? The product of any two integers is odd. Suppose m and n are any odd integers. When any odd integers are multiplied, their product is odd. Hello. It's good logic. This is the sort of logic that my 4-year-old uses. Okay. So, moving along to number 5. Now, some of this is more subtle. Some of these other problems have been pretty obvious, but this is a little bit more subtle in my opinion. But again, you have the statement that we've neglected to write down, but the product of any two odd integers is odd. Okay, well, let's actually start a proof. So suppose that m and n are odd integers. We must show that mn is odd. This means there exists an integer s such that blah, 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 blah. Okay, so here is the issue, is that this is clunky. It's hard to read. Readability here score is low. The idea is not hard, that m and n are odd, and so when you multiply them, you get an odd. That's not hard. But we've thrown a couple of sentences into variable n that we don't need. Yeah? So like what I think and the way that I sort of go about this is that this sort of thing is in your scratch work. Like you're writing down what you need to show for yourself, right? Your reader read the thing. They know what you're trying to prove, right? So write down in your notes, in your scratch work, want to show this. And then what you get to assume. So that whole part in orange, I will just leave in the scratch work. I'll leave out of the formal proof. And then, so then you would say, by definition of odd, there exists integers a and b such that m is 2a plus 1, n is 2b plus 1. M times n is this thing. Do you see a problem now?
Show how 2a plus 1 equals 2b plus 1 equals 2s plus 1.
Yeah, there's a big jump right here. And also, those equal signs are not vertically aligned, and they should be. And that feels hard because you're like, oh, it's just one line. I'm going to waste so much paper. Yeah, you are. You're not wasting paper. You're using paper to make your work look neat. So, Janai, you don't care about using paper. You use all the paper. That's good. So, what we're going to do is say, okay, we're going to just go over here. Mn is 2a plus 1 times 2b plus 1. We're going to work that out. 4ab plus 2a plus 2b plus 1. And then that's going to be 2 times 2ab plus a plus b plus 1. And again, like that extra variable introducing that s is just very unnecessary. Yeah.
So I don't know if this is something that they did wrong, but like you said, especially with what you have in the highlighting portion.
Yep.
The part where they assume the end part is correct, is that something we can do, or is that something that we should save for later?
Yeah. They're not assuming it here. They're telling the reader what they're doing.
Okay.
Yeah. That we have to show there exists an integer such that this is true. Like they're saying we have to show this, but that's it's very confusing to read it, right? Because it does sound like these two sentences flow, but like if you read just this one, it does look sure like they reached the conclusion already. So why are we doing this? Yeah. So I think that's why this is like they're telling us where they're going. They've written down all of the steps right here, which, well, they've written down the like destination right here at the beginning, which is unhelpful and also makes it hard to read. So yeah, like the way we do this in our scratch work is like, well, we want to show that mn is equal to 2 times some integer plus 1. And I don't put a thing here because I don't want another variable that I have to define, right? what we're going to do then is say, okay, well, this thing, 2ab plus a plus b, is an integer. Therefore, 2 times it plus 1 is odd. So mn is odd whenever m and n are odd. What do you think? Making sense? Any questions? No? Was that a yes or no? It was a no. I know I did ask 2 questions. You're right. Where your answers mattered differently. Yes. Okay. Oh golly. Y'all, was it in here that it was so loud? No, it was in my 12:30 class on Friday that was very, very loud. And then I found out later that he was mad. And I was like, yeah, I actually could tell by the way you were writing on the chalkboard how mad you were. Just fascinating. That's why you should write on an iPad so nobody knows how mad you are. Except for the iPad. Okay, number 6, we have here this piece of a proof. Suppose m is a particular but arbitrarily chosen odd integer. Okay, slow your roll. Like, those are a lot of words that are unnecessary, but whatever. If you wish to speak like that, that's fine. By definition of odd, m equals 2a plus 1 for any integer a. Subtle problem, but big problem.
There's some grammatical problems here.
Yeah. M is a particular odd integer, right? If you say that a is any integer, well, then m is all of the odd integers, right? M is a particular, once you choose the odd number, the a is chosen for you, right? So this is for some particular integer a. What is happening there? Suppose p is a prime number. If p is prime, then p cannot be written as a product of 2 smaller integers.
That's what prime means.
I mean, smaller, that it's very confusing, right? It is, they're smaller integers, y'all don't know the definition of composite yet, I guess. Except that it's not prime. Yeah, so composite means that you have, oh no, not that. That p is equal to, we probably shouldn't call it p because that sort of implies that it is a prime. Let me use a different letter. That n is a, b, and a and b are between 1 and n. And that's a composite number. So that is sort of, but like, that's a terrible proof. I don't even, what, it, no, just whatever. I don't know. That is unclear. Also, this sort of thing is annoying. This may be why it's here. This sort of thing is annoying. If p is prime, well, you just supposed it was. So, like say since P is prime, use since as your transitional word there. Right? Does that make sense? They're like, if P is prime, well, friend, you just told me it was, so why do we need to say it, right? We don't. Y'all, it really annoys me when people call people friends that are not their friends. You know, like, you've heard this, like pastors or whatever, motivational speakers, they'll be like, friends, my friends, today, blah, blah, blah. Like, I'm not your friend. And now I'm not listening to what you've said because I'm offended that you think we're friends already. Y'all know what I'm talking about? Now you're going to hear it and you're like, oh. Or maybe you do that and call people your friends who are not your friends. It's weird, y'all. Yeah. Maybe if you're talking to like a group of your friends, that's fine. But if you're talking to a group of strangers, that's pretty weird. Right? Corey, what do you think? You think I'm wrong?
Well, I've never noticed it before, but I think now I'm going to
Yeah.
always introduce myself as hello, friends.
Hi, friends. Oh, like what if I walked in here on the first day? I was like, "Hi, friends. I'm Dr. Thomas." Y'all would have been like, "Oh my gosh, we're getting out of here." Does anybody else teach this class? Unfortunately, no. You're stuck. Anyway, that would have been a lot. If one of my professors had done that, I would have been like, "See, Jacob thinks it's a lot." Made him leave.
It sounds like something like a preschool teacher would do. Hi, friends.
Yes, they do. They don't call them children. They don't call them students. They call them friends. We had a friend today who was sick. That's what, like, my daughter's teacher will tell me. We had a friend who was sick today, or Ellie got hit in the head by a friend today. Like, that sounds like something a friend would do. Hi, friends. Whatever. I feel the same way when people call me Miss Emily. So, like, they don't do that here. No one calls me Miss Emily here, thankfully. But like at church or something, Miss Emily. I didn't choose to teach preschool, and maybe it's because somebody calling me Miss Emily makes me feel uncomfortable.
Maybe like another adult calling you that.
Or children, just call me Emily. But yeah, adults calling me Miss Emily is weird.
Yeah.
I helped with the children's church, and one of the adults introduced the child as Mr. I'm like, you're like, this feels so weird.
It's a respect game then.
Yeah.
Yeah. Well, then maybe that's why, because I'm not going to call this child Mr. whatever. So please don't call me Miss whatever. Let's just be on a first name basis and agree to treat each other well instead of pretending to by calling each other Mr. and Mrs. whatever. I don't know. But that is why people do that. They're stuff too, to put them on the same level so the kids feel safe.
I was talking about introducing me as Mr.
Oh, I thought you meant the child.
No, the adult was introducing me. I'm like, this is weird because you're like, I'm still a kid-ish.
Yeah,
at the
right,
time.
right. I thought you meant that he was introducing the like 4-year-old to you as
No,
Mr.
I was like 16. I'm like, I'm not.
Please don't call me Mr. Okay. We're going to prove that this statement is false. That there exists an integer n greater than or equal to 3 such that n squared is prime. When we want to prove a statement is false, what are we actually proving? That the negation is true. What is the negation of this statement? For all integers, m greater than or equal to 3. Oh, I wasn't going to do scratch work. Do you want me to do scratch work? I was just going to start writing a proof and hope for the best. Don't do that yourselves, maybe. I don't have a ton of space. I don't know. How should we start our proof? Good. Check. 1 point. What? Yeah, okay. We're going to assume instead of supposing, but yes. Michael, what should we assume?
That n is an integer that exists.
Yes.
Suppose one that doesn't exist. Just in case. You never know.
Okay, so m is an integer greater than or equal to 3. I didn't know how to say that more concisely than that. So remember, primes would factor like 1 in itself, right? So m squared minus 1, what does it factor to? Okay. M plus 1, what's the smallest that it can be? When m, because m is greater than or equal to 3. So, yeah, so m plus 1 is greater than or equal to 4. What about m minus 1? It's greater than or equal to 2. Neither of them can be 1. So m squared minus 1 is not prime. For a number to be prime, you have to be able to factor it like 1 in itself, right? So 3 factors to 1 and 3. Those are the only factors, right? This factors to m plus 1 and m minus 1, but m is greater than or equal to 3. So m plus 1 can't be 1. The smallest it can be is 4. M minus 1, because m is bigger than or equal to 3, the smallest it can be is 2. Right? So since neither of these factors is 1, you found a factorization of the thing that isn't 1 in itself, so it's not prime.
Will we ever do prime numbers that are
So the 1 is easier to claim than the other thing, which is why I'm doing that. The
so if it can't be one, then it can't be any other prime number.
no, if the one of them's not 1, then the other one can't be the big number itself. Shoot, where is this definition? Primes are hard to work with. Primes are difficult to like sort of wrap our heads around. Here, there it is. So this is that this, if n is prime, n factors to a times b, where a and b are 1 and n. So 1 of a or b is 1, 1 of a or b is n. That's how you know it's prime. Yeah. So we would like to say, well, with what we're doing, this one is 1 and this one is m squared minus 1. But this can't be 1 and this can't be 1, so the other one can't be m squared minus 1, so this thing's not prime. We have to be able to factor it to be 1 in itself. If we can show that there are factors that are not 1 in itself, then we have shown that it's composite or not prime. Yes or no? Maybe.
Can we write that?
I'm working on it. No, I'm sorry. Notice m squared minus 1 is equal to m plus 1, m minus 1. Since m is greater than or equal to 3, m plus 1 is greater than or equal to 4, and m minus 1 is greater than or equal to 2. Thus, neither, IEI?
Yeah.
That's neither. You just write them where they look similar enough and then nobody knows. That's neither m plus 1 equals 1 or m minus 1 equals 1. We have found factors of m squared minus 1 other than 1 and m squared minus 1. Therefore, this is a lot of words. Therefore, m squared minus 1 is not prime whenever n m is greater than or equal to 3. This will help you with the that one on homework 4, that's 6n squared plus 27 or something. You want to show that that factors exist that aren't 1 and itself. Okay, questions about number 1? Does that make more sense now with it all written down?
Wouldn't you technically use nor? Does neither m plus 1 nor?
Yeah. Watch my avoidance of the issue. Okay, what do we think?
So as far as like homework and future tests go, if we get another one on words, prove the statement as follows. Like, I guess what I'm asking is, do we have to outwardly state we're proving it's false by doing the negation, or do we just write negation and then just go right into the proof?
Yeah, I think it's fine. Most of the time, we're not. You're not going to be doing that anyway. You're going to be proving statements. Right now, we're trying to get the hang of a statement or its negation has to be true. Yeah. Eventually, this first test, there will be some that approve or disprove, and yeah, I mean, as long as you write down what the statement is that you're trying to prove, I don't care that you tell me that you're proving that the negation is true to show the statement is false. Again, that creates a lot more words and makes something that's not complicated to me read hard. That didn't make any sense. It's fine. Good. Okay. This is the part about y'all doing that online homework that is troublesome for me, is that the way that our textbook writes the proofs, I find to be clunky and wordy. And so when you're doing the ones where you're like filling in the blanks, I'm like, well, I wouldn't even say that at all, you know? So take some of that with a grain of salt. But the ones that are like, organize this stuff, they can be challenging, but it's useful to like read somebody else's proof and how they organize things. It's good to see a different perspective, right? If you only saw my proofs ever and then you walked into an abstract algebra class, then it would be shocking. So it's good for you guys to look at the ones the textbook does, but it is, to me, they are sometimes sometimes I feel like Kevin from The Office when I write proofs versus our textbook writing proofs. Like, why use many words when few words good? So like that's how I feel when I'm writing proofs, and our textbook is, I don't know, not that. So you know, everybody's going to find their style, right? It would be okay to do that. I'm not going to require you to say I'm proving the negation and therefore proving the original statement false. Like, no, no, that's not the point. Okay. Prove that there is a perfect square that can be written as the sum of two other perfect squares.
I wrote a right triangle.
Nice. Nice. Very good. Did he put numbers on it?
3, 4, 5.
There we go.
He's a really smart brother.
How old is this brother? Good Lord. He should do Scholars Academy stuff here. Not yet. Maybe he could. I don't know.
I don't know.
My husband's the advisor for that. We could talk to him. Is he homeschooled?
Yes.
Yeah, then he could start taking classes if he wants. May as well. It's really cheap. Like, stupidly cheap.
The other thing is, my family lives like out there. It's farther up in South Carolina. So
Oh.
far away.
There are a lot of online ones. Okay. Why went there? I'm sorry. I don't know. Let's do this. Perfect square that can be written as the sum of two other perfect squares. We're going to start our proof. Consider A equal to 3, B equal to 4, and C equal to 5. Notice A squared plus B squared equals 3 squared plus 4 squared, which is 9 and 16, which is 25, which is C squared. We have shown there exists a perfect square that can be written as the sum of two other perfect squares. I'm actually going to do some scratch work on the next one. Do you feel like you're doing okay so far? Okay. Now, in the past, I need to talk to you about this. I'm so sorry. Starting in COVID, when there were students who were in the classroom and students who were at home taking tests, I let my students have a note card for tests because I couldn't control what was happening in their homes, right? Like they were on screen, but I don't know what's on their desks around them or if they have something posted on their wall or whatever, right? So to sort of make my in-class students feel a little bit better about what could be not fair to them, I'll let everybody have note cards. Now here's the problem, as I think, and I was not even going to bring it up with you guys, but Eunice asked me about it this morning, so there's at least knowledge floating around that I have in the past allowed note cards. But here's the issue, is that like on this test, like 3 definitions, even odd prime, you also have like those rules of inference, and you have common logical equivalences, and you have the conditional, contrapositive, converse, inverse stuff, right? In my opinion, those are all things that you should memorize and know for the rest of the class. So like I would really like for you to not have note cards. But was any of you like banking on that? You're going to be okay without it, right? And you see what happens is they had note cards, so when they screwed something up, like writing the negation of an if-then statement, you best believe they didn't get any points for it. None. You have a note card. Why don't you write down what the negation of a conditional is? Like, come on, you know? So I would get really mad about that sort of thing. So I think if you're forced into, like, now make a note card so that you have the things on it that you know you need to know, maybe, or flashcards or something. But I think it's going to do us all it's going to be better for all of us, me in this class and you and your next classes, to not have that crutch. So we're going to back off the note cards, but I will grade more friendly than I would grade students who have note cards. Does that make sense to you guys?
Yes.
Okay, and nobody's going to go talk to the dean about it. Janaya, are you going to go talk to the dean about it?
No, I don't even know who the dean is.
Okay, I won't tell you. It's Dr. Ashby. You go talk to my chair, that's Dr. Dawson. I got a lot of bosses. You could go above that to Dr. Wilder. You could go above that to Dr. Faulkner, I guess. All right. Do you want me to write down that chain for you? First stop, Dr. Keith Faulkner. I have a problem with that, Dr. Thomas. Tell him my name is Ryan. Ryan. Okay. All right. Prove that the product of two odd integers is odd. How shall we do this? Well, I'm going to do scratch work. Hi, Eunice. We just discussed not having a note card for the test for Friday. Okay. I did also tell them all the things that they should probably memorize, though, that would go on a note card. I'd listen to that part of the video. Yeah. Hopefully there's sound. Yeah. Sounds good. Okay. Prove that the product of two odd integers is odd. What should we assume? Shall we write this as an if-then statement? Do you want to? What do you need to do here? Do y'all have any idea what to do?
This right and an M that are odd.
Okay. So we get to assume M and N are odd. Can we use K's and L's? And what are we trying to show?
M plus N is equal to 2 times some integer.
M times N, but yes, 2 times some integer plus 1, right? Okay. How shall we go about that?
Substitute, put 2k plus 1 and 2l plus 1 into the M times N.
This morning I got up at 4:30 to do the energy, to do something I didn't have the energy to do yesterday. And I was writing on paper, and I was doing the thing again where I tapped my actual pen to erase something. It doesn't work with an actual pen. Yeah, give it a shot, Brian. You let me know if I'm wrong, but
Right, it doesn't.
I didn't have success, so. And also I was using an actual pen, so it couldn't erase it. You know, it's whatever. I was like, oh, yes, it's early. Okay, proof. Oh, the statement that we've made is that, whatever, it's right here. Yeah, that's what we're proving. Okay, who wants to narrate the proof for me?
You would let M and N represent two odd integers. by definition, m is equal to 2k plus 1. And n is equal to 2l plus 1. Now consider,
Ooh.
oh yes, for some integers k and l. And now consider m times n, which is equal to, and then we put in the scratch word. Because 2kl plus k plus l is an integer, then 2 times 2kl plus k plus l plus 1 is odd. Therefore, when m and n are odd integers, their product is also odd.
Good. Questions for Corey? Y'all can't tell that those are in two different colors, can you? You wouldn't know if I didn't say so, or would you?
I mean, I noticed.
Okay.
More on the right side.
Yeah. That's a good.
Okay. One is green and one is black. Maybe I'm color deficient. It's hard. I can't see. I can see that they're different shades of black. Okay, ready? We've almost done it. When I got word that there was a tropical storm, I was like, oh my gosh, here I was thinking we were going to get through all the notes, no problems, and not move the test one for the first time ever in my career teaching Discrete. But then we're here and it's going to be fine, and we're going to have a test on Friday, and it's going to be great. Great, great, great. And the tropical storm is also here, maybe. That's nice. I bet so. Could you tell that a tropical storm was incoming?
Well, the waves were like super turbulent.
Okay.
Some people were surfing in there, which was really dumb.
Yeah, that's not smart. That's true. Okay, I'm going to write this statement as a if-then statement so we can write its negation. Or do you want to just negate it? Do you know what the negation would be? What?
The difference of these two odd energies is not odd.
Yeah. Can I go with even, or do I need to write not odd? I'm going to write even. We did have that definition that every integer was either even or odd. Okay. So what did we get to assume over here?
It's the same M and N are odd integers with,
And what do we want to show?
M minus N is
Good. So if we do m minus n, we have 2k plus 1 minus 2l plus 1, which is 2k plus 1 minus 2l minus 1, which is 2k minus 2l.
So when we write the proof, are we writing it in support of it being even or disproving? Like, do we go back to the original statement to tie it back and say,
Yeah, that was Corey's question too, and I don't think that I care. I think if you say like, if you write on your paper, disprove this, right? Like if you write, disprove that the difference of any two odd integers is odd, then in your proof, I would like for you to do that. So you would say, I'm going to disprove this by proving the negation, blah, blah, blah. So I'm going to prove this thing. Or alternatively, you can write down negation, just the negation, and then just prove that, and don't worry about tying it back to the original. I mean, like the thing that we are all accepting as fact is that a statement that in a statement, it or its negation has to be true. So if you prove its negation, I think it's obvious that you have disproven the original. But if it makes you feel like more, I don't know, accomplished, or like you've, I don't know, do what you need to do.
I have a question about negation.
Yep.
Why do we say any two odd integers and not their x's? Like, because usually when we do like the negation.
Well, because I tried to do that, but Emily told me not to. So well, Emily said no. Emily was ready to go. But let's do it. So let's rewrite that statement, Eunice, as an if-then statement. So we would write if m and n are odd, then m minus n is odd. That's the if-then statement, right? So its negation would be p and not q, right? So it would be that m and n are odd, and m minus n is not odd. And so then that and like other, saying it, whatever, is that the difference is not odd. I find it easier to do this thing, to go back, write down the if then statement and then negate that so that it is clear what I'm allowed to assume and what I'm not. Okay. Okay, who would like to dictate this proof for me? All right, let's go.
Let m and n be odd. By definition, m equals 2k plus 1 and n equals 2l plus 1 for some integers k and l. Notice m minus n equals 2k plus 1 minus 2l plus 1.
Equal signs got really strange there. Okay.
Since K minus L is an integer, 2 times K minus L is even. Therefore, the difference between two all integers and n is
I don't want to write that many words. Is that fine? Are we on the very last problem now?
Yes.
You ready? Prove or disprove. That's a cruel thing for me to put on an exam, just so you know. I would tell you, I will tell you, probably. I will attempt to remember that. I think that, like, deciding on a time test when you're trying to decide if you're supposed to be proving something or disproving it, that can be pretty challenging. If you are supposed to decide, we'll make it be clear that we'll make it obvious, you know. But it won't be something that takes a lot of your time because that's all right. So for all integers, n squared minus n plus 11 is a prime number. Brian says no. Why?
N equals 11.
When n equals 11, what's true?
It's positive. The 11 nicely cancels out with the other one.
Yeah. That looks like the absolute value of 2 in both of those spots. Those are ones. Brian said to try n equals 11. Well, when that happens, these go away, right? So what you're left with is whatever is here squared, which is by definition not prime, right? So that works. So you would say, I don't know, let's see. So we are disproving this. So we are going to prove that there exists an integer in where n squared minus n plus 11 is not prime. don't know if I made that, if that many words made that confusing, but let's read it. There exists an integer n where n is squared minus n plus 11 is not prime. So find that integer. So consider n equals 11. Notice n squared minus n plus 11 is 11 squared minus 11 plus 11. That's 11 squared. 11 squared is 121, which is not prime. Okay.
Dramatic effect.
We did it. Packet number 1. Now I gotta write packet number 2. I'll do that. Don't worry. Don't stress. Don't panic. I also need to write your test. Do you have other homework questions you want to talk through? Eunice, we did make the correction on homework 4 to make that 6n squared. And we talked about on homework 3, we talked through number 5 and how 1 through 5 are not formal proofs, just discussions. And then 6 and 7 are formal, and so are 9 and 10. Michael, what's your question?
I was gonna ask, is the test gonna be written out just like how this is, and then can we use like scratch paper to go with it?
I wasn't going to do that. Do you want it to be that way?
I just didn't.
I was gonna print it where you had enough space, sort of like our notes, where you have enough space to work. But I could, if you wanted me to, print it all on one page and then you can do your work on. That'll probably be easier for you, Eunice. I might do that. I don't know.
I like the one where you put the number and then a lot of space so I can do scratch work to get it wrong and then put the right answer on paper.
Was that both things? Am I the only one that didn't understand that?
The one where you put room for the answer.
You want room for the answer on the sheet, on the test sheet, but also scratch paper.
For myself.
Okay. I'll bring scratch paper with me. You can't use your own. I don't know what's going to be on that. So I'll bring you scratch paper and I'll also leave room on the test for version 2 or 3 or 4. Use a pencil. Maybe that would help. I also don't do math in pencil, so I can't talk. Okay, other questions? Y'all packed up your stuff. You don't want to ask me questions. Yes, go. Stop it. Don't do that. Don't do that.
What do you mean by explaining?
Inverse error, converse error, modus tollens, modus ponens. This is all. Valid because of this, invalid because of this. Yeah. Oh, no. Mm-mm. No, those like you'll just put in symbols and then it'll be obvious. Like this is modus tollens, modus ponens. They've made a converse error. They've made an inverse error. Only 3 of them there, so who knows what 3 of those 4 I chose to put on your homework. Other questions? I like that Jesus is a professor one. It's nice.
I don't know why, when I read that the first time, my mind didn't even read Jesus. I read Jesus.
Maybe it is Jesus. That's Dr. Jesus to you.
I don't think we've established that he's a professor, so.
Oh, fair enough. Fair enough. That's funny. Other questions? Y'all got this, right?
Yeah.
Okay. Okay. You're going to turn in homework 3 to me tomorrow. I'm going to give them back to you. Well, I don't know. It would probably be best if you turned them in electronically, so I could email them to you on Wednesday after I grade them. If you want quick feedback. If you want to pick them up Thursday here, that's fine. Turn it in on paper. You with me?
Yes.
I'm not going to scan your paper homework and email it to you, though. Like, I don't have time in my life for that. Okay? So if you want it back Wednesday for studying purposes, email it to me tomorrow. And if you would just pick it up Thursday, then you can bring it tomorrow to give to me or to Rachel. And then Friday when you come in, you're going to turn in homework 4 for your test. You should do it before then.
For the test.
I mean, like, yeah. You wouldn't believe, Brian, how many people are like, I'm not turning it in by midnight tonight. Like, but you had a test over the material today.
I was imagining someone completing it during the test.
No.
It's
No.
like, hey, it's due at the end of the test.
No, but they're like, I'm gonna turn it in later. Like, what? Why? You should have done it for the test to make sure you know what you're doing. Yeah. Okay. I'm not gonna keep y'all go. Have a great day. Have a great week.
I'll try not to do it during the exam.
Good. Maybe you will do it during the exam. Some of the questions might show up there. Wouldn't that be nice if you? Yeah.
Anything that's due before class is usually due by the end of class.
Yes. True. I'm pretty sure we could argue that here. But yes. I don't know what to do that I've finished thing. We've finished.